Okay, let's get started. Let's see, my name is Robert. I've been with ICP-DOS for over 10 years. Today, we will go over our topic of an engineer's guide on how to make a data acquisition systems. If you have any questions, please feel free to type them in the Q&A box and we'll answer them at the end. Or if you want, you can ask them live at the end of the presentation. Let's see, our contact information is shown here. You can reach us at sales@icpdos-usa.com or phone us at 310-517-9888 if you have any questions, or we can help with any product selection. Okay, here's our agenda for today. First, we'll go over how to choose a sensor for the best results. For data acquisition, it's very important to choose the proper sensor, which will give you the best results. Software considerations. We have a few software packages which we'd like to show you. It's our Easy Datalogger package and our InduSoft/AVEVA Edge software, which can be used for data acquisition and some controls. Remote data acquisition, we'll go over some of our remote data acquisition modules and show you the advantages of using them as opposed to a directly connected PC with a I/O card, especially for manufacturing. Data acquisition modules can be beneficial. We'll show you how to put a system together, and we'll finally end with a Q&A session at the end where I'll answer any questions on any of our products or any of the topic that we went over today. If you have any questions, again, please ask or type them in the Q&A box or ask them at the end of the webinar. Let's see. ICP-DOS was established in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP-DOS USA, which is us, was launched in 2001 to support the North and South American markets. Most of our products are RoHS compliant. We meet ISO 9001 certification, and we're a Microsoft embedded partner for many years. Let's see, keys to building a data acquisition system. The first thing you must do is define the system parameters ahead of time. It's oftentimes skipped, but a well-planned out system will give you the best results. Choosing the proper sensors will also help greatly because you want to have the sensor so that it can measure your data accurately and within the parameters which you choose. And then we'll go over how to choose the proper hardware to best implement the system design. Ideally, let's see, it should be either directly connected to a PC, which will be running software, or connected to an embedded or standalone system for data logging. Choosing the proper software which can meet your data acquisition goals. Oftentimes, expandability is not planned ahead, but if you plan ahead for future expansion, with that in mind, you will have some ability to add on to the system as opposed to start from scratch, which oftentimes happens if you don't plan ahead because limits are reached, hardware is misspec'd, or the processor is not fast enough, as some examples. Okay, the components of a data acquisition system. A basic data acquisition system includes sensors, hardware to connect the sensors to like a PC or a data acquisition system, and software to data log. Some hardware can do data logging as well, so that's included with this. But the idea is that the system contains both the sensors and the hardware which will do the data logging, along with the necessary software or add-ons to do the data logging. The role of the sensor is to detect presence or absence of objects for discrete sensors, and for analog sensors to provide a numerical measurement like temperature, measurement, and rate, which can be interpreted into a data log and scaled so that you can read what you want, whether it be a percentage, the actual temperature, velocity, acceleration, quantities of production, humidity values, occupancy, any of the above. But the idea is that you want to have the proper sensor. We'll go over that in more detail shortly. Hardware is also important, like a PLC or remote I/O modules are oftentimes used to convert and interpret the values from sensors to desired values and to achieve the desired data acquisition log, which involves both logging and reporting. So in other words, if you don't choose the proper hardware and the hardware doesn't connect to the proper sensors, you need to go step by step by step. First thing I would suggest is choose sensors, followed by picking the hardware to match the output of the sensors, and then from there, choosing the software package or protocol which you need to connect to the software. I'll explain a little bit more of that in the few slides from now, but if you have any questions at the end, I'll be happy to go over any hardware or software questions you have. Sensors. Sensor selection can be the key to getting the best results. The selection criteria for discrete sensors, it must be able to sense the objects accurately and precisely. Limit switches, inductive proximity sensors, capacitive sensors are just a few types of sensors, but you need to make sure that your object, whatever you're trying to sense or count or measure, like if you're measuring temperature, well, I'm sorry, for discrete, not so much, but presence or absence is what discrete sensors are. So it's either a 0 value for no or a 1 value for true. So an example of that would be like detecting a bottle either at a place where it can be dispensed or not present. Analog sensors measure values. So for instance, it can measure something as simple as temperature with a thermocouple RTD or thermistor. You can also use 4 to 20 milliamp sensors. There are benefits to that, which I'll go over shortly as well. But analog sensors, again, measure values, whereas discrete sensors are either a 0 value or a 1 value, meaning true or false. Okay. Discrete sensors. Again, discrete sensors must be able to detect the object. So many times, objects may be out of range, the wrong type of sensors chosen, but we'll go over a few hints as to how to select a sensor. But please feel free to contact any of the sensor experts listed at the bottom. Banner, Turk, Omron, SICK, they all make proximity sensors and specialty sensors which can be used for certain types of application. Like specialty sensors would be like detecting opaque objects, being able to detect hot elements, being able to detect fine elements like the teeth on a comb or legs on a IC, integrated circuit, high speed if needed. Some objects pass by conveyor belts really fast and need to be counted, whereas others you need to detect presence or absence simply. Slow moving objects like, for instance, bottles or cars or vehicles or people, those are considered slow speed because if you can visually see them. Other objects like are very high speed and pass by really fast, or are very tiny, or specialty surfaces where an object cannot be detected by the eye. For instance, infrared labels and stuff oftentimes contain certain colors which are used for packaging and for processing. You want to be able to pick a sensor that can accurately detect the object that you're trying to detect and only that object. Laser, slot, proximity, and transparent object sensors are some of the specialty types, but please feel free to contact us if you have any questions or a sensor company to choose a sensor. Discrete sensors, common errors. Just wanted to briefly go over this because oftentimes customers will call us with questions about their data acquisition system not being able to count properly or recognize objects. Oftentimes that has to do with the sensor itself. The sensor itself, for proximity sensors, you need to be careful about mounting these sensors. They have very short ranges and very small envelopes. For most industrial proximity sensors, the cylindrical type, you need to be aware whether it's shielded or unshielded, because oftentimes if you mount it too close to an object, well, actually, I'm sorry, mounting it very close is a good thing, but if an object is not, what do you call it, directed or placed so that the sensor can detect the object at its furthest point along a certain boundary, it won't detect the object and therefore it'll miss a count. Also with some switches like limit switches, you need to be careful about length of and type of actuator arm. Sometimes they're liable to have double counts if the object, say, bounces or is light. Let's see, capacitive sensors, they will detect virtually anything. So if any other objects like an arm, a dispensing arm, even something small on the conveyor belt or something can be detected as an object. So you need to be careful about that. Photoelectric sensors, there are many specialty types of sensors which can detect things like transparent bottles, labels, odd surfaces. You want to make sure that like reflective objects are not used with photoelectric sensors as well, because they can trigger a false count. Angled packages can also trigger, false counts and false detection. You want to make sure that you choose the proper output type. For discrete sensors, the most common types are NPN or PNP type, but there are also AC outputs, triac, relay outputs, many different types, but you want to be able to know which type and choose a common type is the best practice for proximity sensors along with data acquisition. Normally they're NPN or PNP at 24 volts, but we have modules and hardware which can detect additional types as well. Switching frequency, you need to also be aware of that. For high-speed applications, you need to be able to have a sensor which can detect the object and trigger the output based on that speed. Some sensors rather have counters built in, so you need to be careful about those as well, because those are not going to be discrete output. Those will be analog output, because the output of it is actually a count as opposed to just an on-off signal. Analog sensors, again, the most important thing is it must be able to detect the object accurately and at the speed necessary. The typical output types are like 4 to 20 milliamp, 0 to 5 volt, 0 to 10 volt DC, but there's also many others like thermocouple type, there's load cell, there's counters, many types of analog signals, but the main thing is analog sensors provide numerical data on the output or a percentage, and they provide a voltage or current or some sort of scalable output. A liquid measurement. When measuring liquids, you must be aware of turbulence and foam, condensation, tank diameter for some sensors. Sensor mounting is very important. One thing about sensors also for liquid measurement, you need to be aware of the stickiness of the liquid as well. Oftentimes, if a liquid is, say, powdery, it may stick to the surface of the sensor, so therefore it'll still block the sensor and could trigger a false output. So please be aware of those as well. We'll go over a few more analog sensor things in the next slide. Actually, I'm sorry, 2 slides from now. 4 to 20 milliamp output. I just want to have a brief slide on this because this is what I think is one of the better types of analog outputs. The reason for it is because it can be used to detect broken wires or faulty sensors. If you had a sensor output, for instance, of 0 to 20 milliamps, if a sensor broke or say became disconnected, it would show a 0 value. which can sometimes be considered a true value because it may just be detecting no liquid or no volume or no flow. But if the sensor is broken, you won't know if, say, the liquid is still flowing or if the volume is at a certain level, because 0 is a true value within, say, a 0 to 20 milliamp output. And same with voltage outputs, like for instance, 0 to 10 volts. 0 is a true value. If the sensor became disconnected, you may read 0 in your data acquisition system and still think it's a valid number. But in actuality, your sensor may be disconnected or have come loose. So I like to suggest customers to use 4 to 20 milliamp outputs and to choose sensors with this type if possible. But there's other ranges. Many sensors have choices where you can choose the output type. So this is what I would suggest. And as for scaling, it's a little bit more difficult because, again, 4 milliamps would then be equal to 0%, and 20 milliamps would be equal to your full scale or 100% range of your sensor. But if the sensor, for instance, put out a 0 value, you could detect a broken wire or an error or something wrong with your system and trigger an alarm. Okay, if anyone has any questions on these, we'll answer them at the end. But let's see. Thermocouple sensors. Thermocouple sensors are also oftentimes a little tricky to choose as well. They're used for measuring temperature, oftentimes in ovens or vats of liquid. You want to be able to choose the proper thermocouple, which will give you the best accuracy within the temperature range you want. So for instance, if you're measuring room temperature, you want to be able to detect, within reason, the limits. So say, for instance, it's a refrigeration type application. Maybe you want to go below 0 degrees C, or maybe it's connected to an oven where you want to go up to, I don't know, over 400 degrees Celsius. But you want to be able to choose the thermocouple which will give you the best results, but yet cover the full envelope of the range of temperature possibilities that you will be encountering. Temperature sensors also, or rather thermocouples also, have ranges where they give the best results and best accuracy. So for instance, in the curve shown at the bottom left, it shows the J, K, and T types of curves where it shows the temperature coefficient and the temperature itself. And the accuracy is based on the flat parts of the curve. So for instance, the T-type will give you the best results within the shown range in the blue line, but it doesn't go as high as J-type or K-type. So K-type would be used for higher temperature ranges, J-type would be in the middle ranges, and T-type would be for the lower ranges. So you want to pay attention to the maximum and minimum temperature of each thermocouple type and choose the proper thermocouple, which will give you the best results. And you also want to try to minimize the excess. So for instance, if you were doing a small temperature range between, say, 0 to 200, the best one looks like would be either T or J. K has so much excess because it goes all the way up to 1,372 degrees C. So you'll get a lot of excess and your resolution will go down. So you won't have as good a resolution within the temperature range you want. Here's another example. It just shows with our signal conditioners, which you can also use. Let's see. So for instance, J-type has a temperature range between -40 and 760 degrees Celsius. K-type has 0 to 1,000 degrees, and T-type -100 to 400 degrees. It's best to choose the one with the closest range within the envelope that you choose. So for instance, if you're doing, say, 0 to 150 degrees, T-type would be a good choice because It minimizes the excess, and you'll get the best resolution possible within those temperature ranges. Okay, let's see. The signal conditioner shown here also can be used if, for instance, you have 4 to 20 milliamp output sensors, but you have one temperature. So you only need one thermocouple, and therefore you can use one data acquisition module for everything, assuming that the signal conditioner will put out 4 to 20 milliamp, as opposed to buying a specialty module, which takes into account thermocouple as well. We'll go over some model selection shortly. Sensors connecting to the hardware. Once you pick the proper type of sensor, whether it be a digital input or analog input type, you want to be able to choose the proper hardware to match the sensor output. So for instance, for digital inputs, for our modules, we have various types. Dry contact, which is no voltage. It would be like a switch, a light switch, or a relay contact, or even just a jumper wire could be used to trigger a dry contact input. A wet voltage is like a NPN or PNP. Most industrial sensors would be NPN or PNP, but they're the DC 24 volt type. We also have AC sensor inputs, not as common because industrial controls standardly use AC voltages, or I'm sorry, standardly use DC voltage, AC voltage, not so much. Thermocouple, strain gauge, thermistor, RTD, encoder, other types of analog inputs we also have solutions for, but they're less common. For software considerations, you want to be able to choose a software package or use an existing software package which can achieve the goals of your system. So for instance, if you have a software package in mind, you want to be sure that the hardware is compatible with it and the sensors will provide the accurate data. Data format and protocols are very important for those. Certain software packages only communicate certain protocols, or maybe require a direct connection, whether it be through a PCI card. Sampling rate, you need to make sure that the software can sample the data within the period which you need. Like for instance, food processing, you maybe want to measure temperature maybe every minute or every hour and log that for, say, FDA purposes. But other processes like motion control and applications where things change very rapidly, sampling rate can be, a consideration for high-speed applications, because oftentimes data logging software and data acquisition software are not as fast as some applications require. So usually you'd want to use specialty hardware for applications like motion control, where the motion controller will control the motion and the data acquisition will just monitor, position at periodic intervals or production rates. But you want to be able to choose the proper software which can accommodate your sampling rate. Data format and HMI are InduSoft and AVEVA software. They provide HMI function, so you can create an operator interface on your screen and be able to control and monitor outputs, as well as view and acknowledge alarms, create reports, and communicate to third-party devices. Operating system. Most software nowadays is Windows software, but if you, for instance, have a Linux system, you need to be aware that the Linux operating system may not work with the software. So you need to choose the appropriate package and be aware of all these factors. Let's see, remote data acquisition. These are one of our main product lines. Remote data acquisition have many benefits. The role of the data acquisition system is that it can read in a variety of analog and digital signals, And we have output configurations such as, input and output configurations, which include current and voltage inputs and outputs, thermistor inputs, thermocouple inputs, RTD, strain gauge, and many others, but just to name a few. But the benefits of a remote data acquisition module are they can connect near your equipment and near the sensors. They can be spread out more so. For instance, if you have a Ethernet network in the facility already, they make it very easy to add on and to add on to your current network to minimize wiring. Sensors itself are mounted directly to the module. And then, for instance, the Modbus TCP series shown here, they just connect to your existing Ethernet connectivity and are wired to your PC through your network. And the touchpad shown there is just the HMI that can be used to display and read the data. And it can also do some controls if necessary. But we'll go over that later on if you have any questions on that. But the main thing is be able to communicate the data from the sensors to the PC. Using the remote data acquisition modules, you can mount, for instance, if you have 5 identical machines, you can mount 1 module per machine and wire the sensors to that module, and then only have 1 wire, which is a communication wire, going back to your PC through your network. If you had like a PCI card where you had to wire everything to, or I'm sorry, all your sensors to the PCI card, then, you know, wiring could sometimes be an issue because distance-wise, signal types, and various other factors like maybe wiring conduits and expensive wiring is needed to reach certain distances. Let's see, next. Typical small data acquisition system can be as simple as 1 data acquisition module, 1 sensor. In this case, we show the TM7561, which converts the USB port of the PC into an RS-45 bus to communicate to the M7005 to read sensor data. Simple applications like temperature monitoring, process control, and some food and beverage applications can be achieved using our Easy Datalogger software, which is shown to the right. Easy Datalogger is a simple SCADA software. It can be used for data logging, of course. I can show a simple HMI like a trend curve and some buttons to control and monitor the solution, as well as it can send email alarms. There's 2 versions of Easy Datalogger. One version is the basic edition. The basic edition is free as long as you have at least 1 piece of our data acquisition hardware connected at all times. If you do have that 1 piece of our hardware connected, you can also communicate to third-party devices, Modbus RTU, Modbus TCP, or Modbus ASCII. DCON protocol is our own proprietary one, and the limitations are shown here. The main limitation is 64 tags for the basic edition, which is the free edition. And if you need more tags, you can use our advanced version, which goes up to 1,024 tags. The current price is $729 for this, but you know, since this will be put on our YouTube channel, the price may vary, so please check our website for current pricing information. And if you do want email alarms, be aware that you can only send 2 email contacts for the basic edition and up to 10 for the advanced edition. If you do require more or this software won't meet your needs, please contact us. We'll be happy to help you in choosing your software, or maybe we could even create a custom edition if necessary for you to achieve your goals. Okay, let's see, this is a larger typical application. This just shows a diagram using our InduSoft software package. InduSoft is a powerful SCADA software package which can create a HMI screen on your PC or tablet PC, or you can view it through your phone using a remote viewer. but you can do a lot more with InduSoft than Easy Datalogger because you can be used for creating reports. It can be, you can do fancy animations to create it. You can connect with many different types of databases, including SQL, and you can get a lot more tags. The largest one I've seen is like about 100,000 tags, which is a lot of points, but it can do, I believe, like 5 million tags if necessary in your system. Let's see, with this system, at the top is shown the PC connected to just a simple Ethernet switch, and it connects with data acquisition modules shown in 3 different areas. Each area contains devices which connect to sensors. So whether it be proximity sensors, analog sensors, or any type of sensor, the idea behind this image is that all the data from the 3 areas are connected through the network and connected to the PC, which is running InduSoft. PLCs will be controlling each area individually, but the InduSoft will be used for data acquisition and some supervisory control or alarm notification. Okay, let's see, Easy Datalogger cannot do as many tags, so InduSoft would be what we'd recommend for larger applications. And we do offer programming services if customers need help in setting up a system or creating an HMI for their needs. And we can also help you with hardware selection as well. The benefits of Modbus TCP and Modbus RTU. Modbus TCP is my favorite. I like it because it's Ethernet based, and it is very easy to add onto your network. It's got a web interface where you can connect to the module, view data, use it for troubleshooting, and monitor for any errors. Modbus in general, both Modbus TCP and Modbus RTU are open with no license fees. So there's no proprietary licensing you need for it. It's widely supported by most SCADA and HMI software. It's easy to use and easy to implement. A wide variety of devices oftentimes communicate using Modbus, or we have remote data acquisition modules which you can connect your sensors to, which have these protocols, and they're low cost, and there are many, many resources available for it. There's also Modbus gateways, which can convert Modbus serial data to Modbus TCP data, which is, let's see, Modbus RTU and Modbus ASCII are serial based. You need an RS-485 or RS-232 connection. And then Modbus TCP is the Ethernet version of it. So it helps to bridge the gap. Say, for instance, you had different pieces of machinery, all identical. They would connect to a similar array of sensors and data acquisition modules on the machine, which can be connected serially. And then you can use a TGW module to convert the data and convert the communication to Modbus TCP to add to your network to make it simpler to connect all these machines to the central computer for data logging and data acquisition. Here's a selection guide for our Modbus RTU modules. I wanted to show you this because this can help fill in some gaps. Notice the input range column shown. The input ranges, there's many different ones associated with each of these modules. The most important ones are the ones that will match your sensor. So these must match the sensor output type of your sensors. So you want to match the output of the sensor to the input type of the module itself. If you need help in choosing that, please feel free to notify us. The number of channels, so for instance, that would be equal to the number of sensors. If you had only one sensor, then our I-7012 would be a good suggestion. Or if you have up to 8 sensors, then you can use our, the I would be our DCON protocol, so you'd want to use M7017. We're doing Modbus RTU right now, so ignore the I-7000 series at the top. Differential signals mean that each signal has its own individual ground. When a module has multiple sensor types, you want to look for individual channel configuration shown here at the bottom. For this picture right here, the M7017H and HL series would be the ones with individual channel configuration. Say, for instance, you had some sensors which are 0 to 10 volts, so you can use the plus or minus 10 volt range, and you had others that are 4 to 20 milliamp. Then you'd need to have a module with individual channel configuration. If all of your sensors are common type, you'll save some money and you can get one without that feature. Like for instance, our M7017, which is one of our most popular models, and our M7017C is current input only. So if you do have all 4 to 20 milliamp ones within these ranges, you can select the M7017C. The C stands for current. The voltage input modules can accept current in most cases, but would require an external resistor, so you need to be careful of that. Resolution also plays an important fact or aspect of your system. So you want to be sure that you can get the resolution that you need for your system. If, for instance, you need high accuracy or resolution, then you need to pay attention to getting data acquisition module or data hardware, which will have the accuracy needed. Because if the hardware, even if the sensor can achieve the accuracy which you need or resolution, the hardware also needs to have that ability. Otherwise, the resolution won't be there in your software. Okay. Sampling rate also plays an important fact. For high-speed applications, you want to make sure that the sampling rate the hardware can achieve. For motion control, you want to have something in the kilohertz range. For high-speed counting, you probably want that as well. So you'd want something more powerful than the M7000 series. We have hardware packages which can our PCI cards will give you the fastest resolution at the best accuracy, and they would mount in your PCI or PCI Express slots on your PC and can be connected directly. Since industrial communication has a bottleneck or will create a bottleneck, you want to avoid those for high-speed applications, or pick a protocol or communication method that's fast. Ethernet, for instance, is much faster than serial. So for higher speed applications, you can choose our Ethernet connected module if you need slightly faster data acquisition periods. Here's a sample of our Modbus TCP selection guide. Note the second column contains number of channels. So you can connect up to 20 single-ended sensors or 10 differential sensors to this module. And the sensor input type, or I'm sorry, the hardware input type must match the sensor output type. So those would be shown here. You'd want to match it with these. If you do have questions on choosing the appropriate type, please give us a call and let us know. We'll be happy to help you with that. Sensor input types for specialty sensors like thermistor, RTD, and thermocouple are also shown in this table. So for instance, if you have thermistor inputs, you want to choose one of these modules. The difference between the series is the ETs are standard Ethernet Modbus TCP module. The PET series includes the feature of power over Ethernet. Power over Ethernet will allow you to both communicate the data to the module itself, but also supply power to the module. So you won't need to wire power to the module, even though you may have to wire power to the sensor. So you have to take that into account as well. Okay. Protocol gateways. Protocol gateways are very useful for large data acquisition systems. If you have existing devices like PLCs, HMIs, or sensors that communicate using different protocols, like for instance, if you're going to a SCADA system, you want to incorporate everything into a single driver or single communication type to make it easier, protocol gateways are oftentimes a very simple and economical solution. This particular one is our Modbus RTU to J1939 gateway. J1939 is a protocol which is heavily used in the automotive industry and can communicate to large motors and communicate parameters such as oil pressure, temperature, and RPM parameters. And this module will convert the data from the J1939 protocol and put it into Modbus register so you can more easily connect to your industrial hardware, whether it be a data acquisition system, a controller, a SCADA system, any hardware which can communicate using Modbus RTU can be used with this gateway to read data from the J1939 bus. Okay, we have most field bus converters to Modbus. So for instance, you have J1939, CANopen, DeviceNet, PROFIBUS, PROFINET, Ethernet IP. We most likely have a gateway solution which can be used to convert the data for you if you have the need. The benefits of a gateway. Let's see, here's the list again of most of the ones I just mentioned, but the benefit of it is you can communicate the data through either a different medium. So for instance, this one's Modbus TCP over RS-45 to Ethernet. So instead of going all RS-45, you can connect it to your Ethernet network and communicate the data through Modbus TCP to your PC. We have other devices which can do the various other protocols shown below. Zigbee and Wi-Fi are wireless protocols. So if you do have the need for wireless, as well as Bluetooth, we do have solutions for that as well. And let's see, for most of our protocols like Ethernet IP, CANopen, and Profibus, the quick start guide, we have some FAQs which help you to bridge the gap. So for instance, for our Ethernet IP to Modbus converters, oftentimes customers are more familiar with one protocol, whether it be Ethernet IP side or Modbus side. The FAQ section has a step-by-step guide for how to connect using, in this case, RS Logix to Control Logix PLC. We have that in our FAQ section, so it makes it very easy to follow the steps shown in the manual. Signal conditioners. If you had, for instance, a situation where you had, say maybe 6 4 to 20 milliamp sensors measuring flow and volume or rate, but you also needed one temperature sensor. A signal conditioner would be a great solution for that, because the signal conditioner will convert the thermocouple output of your thermocouple to a voltage or milliamp signal, so you can use a common data acquisition module, which will save you some money theoretically and will save you on the hardware too, because as opposed to either purchasing an extra module for thermocouple input or purchasing a module which has the ability to do a thermocouple, you can just purchase one that does voltage or milliamps and oftentimes save money and save hardware space and wiring. We have various signal conditioners to convert most of the common signals, but these are traditionally just used for like converting one sensor that's stray to another common type. Putting it all together, this again, just a simple Modbus data acquisition system. All the M7059 at the top have sensors connected to it, or would have sensors connected to it. They're daisy chained along RS-45, communicating Modbus RTU. Then the I7561U converts the communication, which is Modbus RTU, through a single USB connection to a host PC. So the M7059 can be distributed throughout your plant or throughout a building and provide data acquisition points where sensors can be wired at different points while only be connecting to each other using a single set of twisted pair copper wires, to thus save wiring cost and number of connections. Okay, expandability. I briefly talked about that, but plan for expansion when creating a data acquisition system. A successful business can expand very easily. Expansion usually includes more production equipment. Choosing reliable hardware once and duplicating it for identical pieces of equipment can make expansion easy. So if you have a production line, you're producing products, then suddenly your business booms. You want to be able to duplicate the system as opposed to having to recreate a brand new machine or a brand new production line to do the same thing with different technology, where you may need someone to program or connect different pieces of hardware. You just want to be able to duplicate it to make it fast to expand. This makes it easy to do it by choosing or planning ahead with software and hardware that can be both expandable and duplicatable. The same can be said for machine upgrades. Sometimes you just need to add a few sensors. Like for instance, if you need to accommodate larger boxes or different packaging, you can use the same production packaging equipment by just incorporating a few additional sensors and adjusting the sensor positions or sensor types to accommodate the new packaging. So it's also very economical as well, because if you plan for expansion, you don't need to purchase something later that can do more. For instance, our Easy Datalogger software is expandable up to 1024 tags. If you get past that, then you can run another instance of Easy Datalogger, but if you want to combine them, you would not be able to do that. So in that case, like InduSoft, which is a full-blown SCADA package, which has the ability to upgrade the number of tags, would be a more ideal solution if you plan to get that high or need that functionality. Okay, let's see, that's the end of the presentation. I'll be happy to answer any questions for you. If you do have any questions, please type them in the Q&A box, or if you want to raise your hand and I will answer them live. Let's see, so far I don't see any questions in the Q&A box. Does anyone have any questions they'd like to ask live? Let's see, if you do, click the raise hand button and I will unmute you so you can talk. No questions. I'm actually surprised. Okay, any last minute questions? If you do have any questions, please ask them now. Otherwise, you can contact us and we'll be happy to help you with any questions that you have. Let's see, our contact information is shown. I do see one Q&A question. Let's see, just popped up. What is the accuracy of your thermocouple modules? Let's see, the accuracy is shown, for instance, for our ET modules. It's defined in the, let me get that document for you. Or actually, I can go back to that slide. Let me find the slide for you. Documents. But most of our modules can be set for engineering or hex format. Engineering format will usually give you 2 or 3 decimal points, but what do you call it? Hex format will give you 32-bit resolution within the full temperature range. So let me just show you this and explain. Let's see, let me minimize this. Okay, so let's see. So let's just use J-type as a sample. So within J-type, the temperature range is 760 to negative, or I guess negative 210 to 760. The module itself will display 2 decimal points for engineering units between negative 210 and 760, or in hex format, which will give you the better resolution. It has this conversion of resolution. So to give you better resolution theoretically within when using hex, but the scaling will need to be taken into account. Engineering units will give you the true value with some decimal points, but you need to add them in when using Modbus. So for instance, it'll give you 21,000 when it's, or negative 21,000 when it's 210 degrees. So you get 2 decimal points of resolution. Did that answer your question? Let's see, where is the internal CJ located and how many? Traditionally, our modules have one, and it's located in the body of the module for our ET series. So the ET series, let me just show you an example. Let's see, let me pull it up over here. Okay, so 7018Z. So our CJC sensor is located in the, here, let me get a picture. Okay, so for this module right here, it's located on the side there or in the daughter board. So with the daughter board itself, which mounts on top, it would be, let me get a picture for you. Okay, so this is the daughter board. It plugs in on top, or let me get a picture. Okay, these are probably better. So it would be here in the daughter board for this module. Other modules which do not have the daughter board, it would be on the bottom left corner of the module itself. So that would be the position of the CJC sensor. And we do have just one sensor in the module. Another question I see, what are the options for retrieving data from Easy Datalogger by other software? Let's see, Easy Datalogger has the option to either produce a TXT file or CSV file, which can be incorporated that way, or you can use SQL. We support SQL Server for sharing data to other software. If you do need other options, InduSoft has much more capabilities in reporting that Easy Datalogger does not. Again, Easy Datalogger is just a basic data logging software. For more thorough applications, we do recommend InduSoft or AVEVA, as they're now known as. Does anyone else have any questions? And Carlos and Jack, if I did not answer your question thoroughly, please feel free to type more. Let's see. Okay, I do not see any further questions. I'd like to thank you for attending our webinar this month and look forward to seeing you next month. And if you do have any questions, whether it be applications, part number selection, or just general help in choosing the right sensor, please feel free to contact us and we'll be happy to help you.